Okay.
Number 4 is a whole nother question. Let's talk about 6. We talked about this a little bit, and the fact that we could take out a cosine squared from the right side, leaving sine x minus 2 cosine squared x sine x plus cosine 4th x sine x. In other words, is all I did to the right side was factor out a cosine squared. Now, you can see on the left side that we have sine to the 5th times cosine squared. So, for the moment, we can assume that this part must be sine to the 5th of x.
Right.
So, let's try to solve sine to the 5th. Now, if we're trying to turn it into something that looks like that, probably the best thing to do is to make it look like this. Understand?
Yep.
And then, every time we see a sine squared of x, let's substitute 1 minus cosine squared. That's the same as sine squared. Times, well, here. The second sine squared is also going to be 1 minus cosine squared of x, all times sine of x. In other words, that's what we just wrote.
Right.
And what I suspect is that when we multiply this all together, we will get that. And that will prove the identity. So, let's multiply the first two parts. What do you get?
So,
you're foiling it. Just foil it.
So 1 minus cosine x.
It ends up being 2 cosine squared x.
Oh, yes. And then plus cosine to the 4th x.
And we're multiplying all of that by sine x. So what does that give us? That gives us sine x minus 2 cosine squared x sine x plus cosine to the 4th x sine x. Now the question is that the same as what's in blue?
Yes.
Sure looks like it. It's exactly the same. So, the only identity we needed to know was that sine squared of x equals 1 minus cosine squared of x. In other words, one of your Pythagorean identities, one of your original 11. There are 11 that you just absolutely have to know, okay, to pass the test. You can add another 9 to 12 if you include sum and difference, double angle, half angle. but the original 11 will get you a long way. Okay, so
Yep.
we've done 6. Let's take a look at 4. I believe that 4 is based on the sum and difference, or not sum and difference, the sum to product.
Okay.
Okay. Now, we can spend 20 minutes doing this problem, and I have no doubt that it'll take that long. But there's absolutely no point in doing it unless you're going to memorize this formula. Unless they give you the formulas before you take the test. Is that true or false? The identity.
I am not sure if she'll give us the formulas.
Most trig classes, they want you to memorize them. They will not give you the 20 or so identities that you need to do these problems. So, if you don't have any, I would prefer not to spend the 20 minutes on problem 4. We can do it, but it's not going to do you any good unless you memorize. And this one is the hardest one of all to memorize. So you tell me what you want to do. We can do number 4, or you can give me more material. In other words, 4 is the only one on this page that we have not done.
Right. Okay. Here, hold on. I think I might have a page that...
Okay. That's the best.
Yeah.
I really hate to spend all of our time doing these super difficult ones that are going to require you to memorize 2 or 3 different identities. I mean, What's the point of that? Are you going to memorize them? If you're going to memorize them, well, I don't mind doing them.
Yeah, I don't know. Because I don't have anything on the notes that she gave us that has the sign 3x.
Well, let's do it. Apparently, here is the formula for that you would want to use. It goes like this. The sine of A plus the sine of B equals 2 times the sine of A plus B over 2 times the cosine of A minus B over 2. Now, let's just look at this part of it. There is another equation for cosine. Sum to product. Notice why it's called sum to product. This side, we're adding them. Over here, we're multiplying them. So, what's A and B?
So A is 1.
X.
Okay, X.
In other words, that's an angle. So's that. What's
B? 3x.
So, if I substitute in over here, I get 2 sine of x plus 3x, that's 4x divided by 2, so that becomes that.
Yep.
Cosine, well, that's 2x over 2, which becomes that. So that's what the numerator is equal to. Now, let's talk about the identity formula for the denominator. I'm going to use different letters this time. I'm going to use delta and epsilon. Those are angles, okay? And the general formula for cosine plus cosine, which is what we're looking at, is 2 cosine of delta plus epsilon over 2 times cosine, guess what it is, delta minus epsilon over 2.
Okay.
So, our denominator, what is delta?
X.
What's epsilon?
3x.
So if we plug that in, we get 2 cosine of
x plus 3x, which is 4x over 2, which is 2x, yeah. And then cosine of 2x over 2, so x, yeah.
All right. So now we have the numerator and the denominator. We just put a big long line between that. Notice the 2's cancel, the cosine of x cancels. What am I left with? Sine of 2x over cosine of 2x, which is equal to tangent of 2x.
Okay.
Okay. So, this was very doable as long as we memorized that formula and this formula.
Okay.
I guarantee you there's only going to be one question on your test that involves this. And in fact, of 10 years of tutoring trig, first time I've ever had to do something like this. First time.
Wow.
I know. In other words, most trig students do not get into sum to product or product to sum. They just don't. That's fine if you're in a class like an honors class or a teacher that really likes to extend the limit, you're going to get a question or two like this. But if you have a minimum amount, let's talk about memorizing stuff, Demetrius. When's your final? Or when's your next test?
Next week.
Okay.
So next Monday.
Trig is all about memorizing. It truly is. Would you agree?
Yeah.
More to memorize in trig than any math you have taken up until now. So, here's the best way that I know of to memorize stuff.
Okay.
Make flashcards. Get some index cards. On one side, write tangent of x. On the other side, write sine of x over cosine of x.
Mm-hmm.
Make another flashcard that says cotangent x equals cosine over sine on the other side. And I think you are probably dealing with about 25 identities that you're supposed to memorize and know, which means you're going to need 25 index cards.
Mm-hmm.
Now, part of the process of memorizing is aided a lot by you making up the flashcards, as opposed to me giving you 25 flashcards and saying, here, spend the next week working with these. When you have to make up the flashcard, that's half of the act of memorizing it.
Mm-hmm.
So I would say you should make it up. Okay?
Yeah.
Just for example, let me put some that I would do in terms of flashcards if you want to pursue this. And so far, that's the biggest problem I've seen with your stuff, is you don't have this stuff memorized yet. And that is going to be extremely problematic if you don't memorize it. You really cannot do these if you don't have them memorized. Okay, so maybe you'll have one card that says reciprocal. And on that card you have sine x equals, you have cosine x equals, you have tangent x equals. On the back side of it, you put the answers. What's sine x equal?
1 over the cosecant.
What's cosine equal to?
1 over the secant of x.
Notice SCCS. First letters are never the same. That automatically tells you what it is. In other words, don't ever make sine x the reciprocal of secant x, because they would both have the same first letter.
Yeah.
And what's the reciprocal of tangent?
1 over cotangent.
Okay. And then obviously the reverse is true. In other words, that's only 3 reciprocals. You also have the cosecant of x is equal to 1 over the sine of x, and so forth. Mm-hmm. So one flashcard might do the trick for your 6 reciprocal identities. Another flashcard, these are the 11 most important.
Yeah.
There's 2 quotients. What are they?
So the tangent of x equals the sine of x over cosine of x, which also equals secant over cosecant.
Well, no, don't memorize that. Memorize the other quotient.
So cotangent equals cosine over sine.
And notice you don't really have to remember that one. In other words, if you memorize that one, you're going to automatically know the cotangent one. Just like if you memorize those 3, you will know the other 3. So even though we're talking about 11 basic identities, you really only have to remember 4 or 5 of them. And your final 3 are your, actually it's called Pythagorean identities. What's the number 1?
So
the one they for sure ask you about all the time and use all the time.
So sine squared x plus cosine squared x equals 1.
Okay. Could have a flashcard for that. Although you seem to know these 11. Now, the next two are a little more difficult. What's the rest of this one?
Plus 1 equals
you need a flashcard for this one.
Yeah.
Okay?
Yep.
Now, the third one you really don't need a flashcard for. The third one is the same as the second one, only using the cofunctions. So what's the cofunction of tangent?
Cotangent. Square root of x.
What's the cofunction of secant?
Cosecant.
That's the third one.
Okay.
Okay? So here's what you need to memorize. Of these 11, 1, 2, 3, 4, 5, 6. If you memorize those 6, you'll be able to figure out the other 5.
Okay.
Okay?
All right.
And you can take a quick picture of this if you want. With your camera, this is critical. You really cannot succeed at trig unless you know these basic 11.
Right.
Okay? All right, I'm going to erase it.
Yeah, go ahead.
And let's talk about the others that are most important. The next one that they're going to ask you about is the sum and difference of cosine. Tell me what that is. And I hope you're not looking this up. In other words, I hope you don't have a book open in front of you and you're just reading it. Let's make sure you're memorizing it.
Right, yeah. These I have a little bit more trouble on.
Well,
the other ones I have kind of.
If you start with cosine, you'll find that it's not that hard. Cosine begins with 2 cosines and 2 sines. So what would it be?
So cosine of A, plus or minus.
Begins with 2 cosines.
Oh, so then cosine of B.
The sign is opposite.
Okay, so minus over plus, and then
What's
sine
the
of
rest of
A.
it have to be? If it's 2 cosines and 2 sines, then what's the rest of it have to be?
Sine of A, sine of B.
Okay. Now, they teach you that one as the first one. I'm not quite sure why, but I think it's because it makes it a little bit easier to memorize this one. First of all, I know 2 things. I'm going to have 2 sines and 2 cosines in my answer. Second of all, my plus or minus sign is the same. And thirdly, they're mixed up. It's not like the cosine where I had cosine, cosine, minus or plus sine, sine. There's a sine and a cosine in each one. So what's it going to be?
So sine of A, or cosine of B.
Uh-huh.
And then plus or minus.
There's only one
cosine.
thing the rest of it could be.
Yeah, cosine of A,
well,
or sine of B.
Let's keep a certain order to it.
Okay. Sine of B, cosine of A.
Yeah, that's the only thing it could be. Okay? And finally, the tangent. Now, what's helpful to know about the tangent is that it's sine over cosine. And if you were to put row 2 over row 1, you would end up with same sign in the numerator. In other words, it's plus or minus. We're going to stick with the plus or minus in the numerator. The denominator is 1 opposite because the cosine is opposite. Notice that it's sine over cosine. The sine is the same, so that's the same as this. But the denominator is 1 minus or plus the product. Tan A, tan B.
Okay.
Which, if you look at it, that's the same as the sine, and that's the same as the cosine, which makes sense because tangent is sine over cosine.
Right.
And the way I memorize this is that I'm adding in the numerator, I'm multiplying in the denominator from 1. I don't know. This is a hard one to memorize. This is probably one of the last ones I memorized was the tangent one.
Okay.
Okay? But these 3 are the next most important. So that's a total of 14.
Okay.
The next are the double angle formulas. What's that one?
2 sine.
Go ahead.
So 2 sine times
2 sine of x. You always need an argument.
Yeah. And then times cosine of x.
That's it. It's the only one we know of. The cosine has 3 of them. And there's a reason for that. It's just difficult to explain at this point in time. When you get to calculus, or even actually when you're solving trig equations, you need 3 of them for the cosine of 2 theta. The easiest one is this one right here. And the reason I call that the easiest one is because it's kind of the opposite of the Pythagorean theorem, right? In other words, it's not cosine squared of x plus sine squared of x. It's cosine squared minus sine squared.
Okay.
There's another one, and these are hard to remember, but there's a pattern to them. And this one is the pattern is this. Notice that it's 2 sine squared or 2 cosine squared in either case. And in this second case, it's 1 minus 2 sine squared, whereas in the third case, it's 2 cosine squared minus 1. So there is a pattern there that's useful to get. That's the only way I have even come close to memorizing them. And the reason there's 3 of them is sometimes you need to convert cosine of 2x into all sines, which you would use this one. Sometimes you need to convert it into all cosines, in which case you would use that one. And sometimes you don't care, as long as it's in cosine or sine. And you use the first one. Okay?
Okay.
So this is 15, 16, 17, 18 identities now.
Yep.
Now, the tangent of 2 theta, you don't really need to memorize that, because guess what? That's the same as the tangent of x plus x. And you can use the sum and difference formula. In other words,
Okay.
if you forget the tangent of 2 theta, which happens to be 2 tan theta over 1 minus tan squared of x, and if I was doing tan of x plus x, the numerator would be tan of x plus tan of x, which would be 2 tan x, and the denominator would be 1 minus tan of x times tan of x. So I can always figure this one out if I know my sum and difference one.
Okay.
Now, that's almost all of them. You would do very well on a trig test if you could memorize all of the ones I've just gone over in the last 5 minutes. But there are 2 more, or 3 more, that you really kind of want to remember. So let's go over those. And this really covers it, not to mention your product to sum and sum to product. I've never ever suggested that anybody memorize those because I've never had anybody that had to know them. But the half angle formula is very important.
Okay.
It's very similar for sine and cosine. Notice that both of them only differ by 1 plus or minus sign. Okay?
Okay.
And the way I memorize this is the cosine is the plus, the sine is the minus. But notice, to solve each one of them, we merely have to know what cosine of x is. Even if I wanted to know, say, the sine of 15 degrees, that's the sine of 30 over 2. So all I have to know is what the cosine of 30 is, and I'm going to have my answer. Same thing with cosine of half angle. I only have to know what the cosine of x is. Now, there is something unusual about these, and that is you have to choose one of those plus or minuses. And it has to be based on what quadrant you know it's in. And the angle we're talking about is that angle there. In other words, it's not what quadrant x is in, it's what quadrant x over 2 is in.
Okay.
And if x over 2 is in the second quadrant, then I'm going to use the positive sign because I know sine is positive in the second quadrant. If x over 2 is in the second quadrant and I'm dealing with cosine, I'm going to use the negative sign because I know cosine is negative in the second quadrant. So it's not about this, it's about what quadrant that is in. And sometimes you have to play around with it a little bit. In other words, if x was 150 degrees, what quadrant is x over 2 in?
So, the first quadrant.
Okay. If x is 260 degrees, what quadrant is x over 2 in?
The second quadrant.
No. Still divided by 2. So it's 80 degrees. First quadrant.
Oh.
That's how you tell, is you figure out what quadrant x is in, how many degrees that is, and divide it by 2, and then figure out what quadrant it's in. So if I gave you an angle of 270, what quadrant is x over 2 in?
The second.
Yeah.
Oh, yeah.
It's
Yeah.
divided by 2 equals 135. That's second quadrant. So if I'm dealing with sine, I'm going to choose the plus sign. If I'm dealing with cosine, I'm going to choose the minus sign in front of the radical.
Okay.
So that's what that plus or minus means, is you have to figure out which quadrant x over 2 is in to figure out which to use, the plus or the minus.
Okay.
Now, the last one that I can think of that I would suggest you memorize is the tangent half angle. And again, it's helpful to know that tangent is sine over cosine, because that kind of tells me if it's sine over cosine, the numerator has to be that, and the denominator has to be that. So you really just have to remember the numerator of the sine half angle and the denominator of the cosine half angle to get what the tangent half angle is.
Okay.
Okay? So that's like 3 more. What are we up to? 20?
Yeah.
It's 20 identities that you could not do anything better with your time than to make sure you memorize those 20 identities. And I mean that, including tutoring sessions with me. I would rather you spend your time memorizing those 20 identities by heart, knowing them instantly, than go through problems, because memorizing these identities is everything. Trig all comes down to just plugging in to these identities. All right.
So I have another.
Okay. Can you verbalize them, or you want to send me something?
I can send it to you real quick.
Okay, go ahead. And you're sending it to David Cowan, 1949? Okay.
And it says sent.
Okay.
Oh, it worked this time.
Yeah, no, I got it. I got to do a couple things here before I can view it. The only way I can rotate it is if I put it under paint, and I can do that. It just takes a couple seconds to do it.
Okay.
So I'll have it here in a moment. All right. All right. Polar stuff. Did we do anything polar at all? I think we did. I saw this problem. Huh?
We did it up to 14, I think, last time.
Yeah. We talked about making a table and plotting points.
We can start at 18 this time since it's a little bit.
Well, I'm trying to figure out if that's the best thing to do. I think it is. I think their intent on wanting you to graph these is for you to make a table and plot the points, and then connect the dots, and you'll get the cardioid, or the
Right.
petal, the flowers, the petals. There is a standard formula for those. Yeah, it might be worth memorizing them, because it's possible that when I look at number 13, I should know that that is either a cardioid or a rose petal. And if I look at number 14, I should know the same thing. And if I look at number 17, I should know what kind of shape that is. However, you don't really have to memorize all of that as long as you can do a table. Because a table, you're going to get a bunch of dots. In other words, you're going to give various thetas and calculate what r is. And then you're going to have a bunch of dots. Plot them on polar graphing and then connect them. And you'll be able to tell whether it's a rose petal or a cardioid.
Okay.
Okay? And that's probably the quickest way to do these. The other way would be to memorize the, and I would have to look it up, but if I had to guess, I would say that's a cardioid. And this maybe is a rose petal. But I could be completely wrong. And I don't really need to know. In other words, if I can make a table, then I'm fine. Now, let's just make sure you can make a table, because that's, if we're going to use that as the key, let's do it. Because you may or may not be able to make a table. Give me various values for theta, and then tell me what r is for each value. Where would you start?
We could do...
Start at 0.
Yeah, 0 for theta.
Okay, so if theta is 0, what is r on number 13?
So cosine of 0 is 1. So
r is 5.
yeah, 5.
Next angle is your common angle, 30 degrees. So what is r when theta is 30 degrees?
So 3 plus root 3.
Next common angle is 45 degrees. What is r?
3 plus root 2.
60 degrees. What is r?
4.
And finally, 90 degrees. What is r?
3.
So let's make sure you know how to graph those. So 0 degrees is that line right there.
Mm-hmm.
So what's the length of that line?
5.
So that dot, here, I'm going to put my dots in blue. That dot goes right there. That is r, comma, 0.
Mm-hmm.
Now let's go up to the 30 degree line. What is the coordinates of that? Hold on.
3 plus,
Oh, okay, 3 plus root 3, which is like 4.7, so it's closer.
Mm-hmm.
And then that's, I'm saying that's a 30 degree line. Okay, and by closer, I mean this is 4.71 in length.
Mm-hmm.
That's the way polar coordinates work. R is the length of that line. Theta is the angle that that line makes with the x-axis.
Right.
If I go up to 45 degrees, 3 plus 1.4, that's 4.1. It's getting shorter and shorter. If I go up to 60 degrees, it's only 4.
Yep.
So the length of my lines is getting shorter, and by the time I get to 90 degrees, it's only 3. So if I connect those 3 dots, that to me looks like a cardioid. If I were to do this all the way around the unit circle, it's going to look something like this.
Right.
Just take my word for it. So that is the general format for a cardioid.
Okay.
Whether you have to know that or not, I don't know. If you always make yourself a table, the problem with making a table is it's extremely laborious. You saw how much time it took us to do it. Whereas if you know that that's a cardioid, you can do it quicker. But I don't even have them memorized as to whether that's a cardioid or a flower petal or whatever. So the only way I would do it on a test is with this table. Once you get a table and you get 4 or 5 points, you can kind of figure out what it is.
Right.
Just by connecting the dots. At least you can figure out the first quadrant. And once you figure out the first quadrant, you can kind of figure out that the only shape that fits is a cardioid there. There's a few pronounced shapes. One of them is a cardioid. Another is a flower petal, like that. And for these, you can tell how many petals they have by the coefficient. 2 or 3 or 4. That'll tell you how many petals they have. But again, I don't even know if 14 is a rose petal or not, to be honest with you. I would make a table and connect the dots and see. And I guess that's what I'm going to suggest to you, since there's already so much for you to memorize. I'm not sure it's really worth memorizing what each of these polar graphs are. Not when you can figure them out by making a table. I didn't get a look at 15 and 16. 16 is kind of interesting.
Yeah.
What is that? What does R equal 2 look like?
So, isn't that just like a straight line up and down at x equals 2?
No, that would be if it was theta equal 2.
Oh.
When you have R equal 2, what it means is it's all the points, no matter what theta is, R is equal to 2. Well, if you connect all of those, what do you get?
A circle.
A circle.
Okay.
Now, at this point, you can begin to see the advantages of polar equations over rectilinear equations. The equation of a circle is this. My God, that's horrible. Horribly complicated and hard. But if and R here is the radius, not the same as this R over here. But r equal 2 is a much, much simpler equation of a circle. And it turns out that when you get into more advanced mathematics, the simpler you can make that, the better. And so polar works a lot better sometimes when you're analyzing stuff like circles. If I had theta equals pi over 4, if I had that equation, well, what is that?
So that would be,
that's your straight line.
Yeah.
In other words,
At pi over 4.
That's pi over 4. So when you have theta equals to some number, it's a straight line. When you have r equals some number, it's a circle of radius, whatever r is.
Okay.
Okay? And it is helpful to know that.
Okay.
It's probably helpful to know whether these are rose petals or cardioids. I just don't happen to know them. In other words, I've never really found that something that it's worth memorizing. But, I mean, that's kind of a silly statement to make, because all of this stuff would be worth memorizing if it's useful. You know, if it allows you to do the problems faster. So, we got about 5 minutes. Number 18.
Mm-hmm.
Before we do number 18, let's do number 19.
Okay.
What's the polar equation for number 19? First of all, what is that in rectilinear? Is that, what kind of shape is that? 19.
That's,
It's a circle.
Yeah.
Of radius what?
Of 9.
No, it's the square root of 9.
Of 3.
In other words, the standard equation in rectilinear of a circle is x squared plus y squared equals the radius squared. So the radius is 3. So what is the polar equation of this?
3. R is 3.
All right.
Which is circle. Yep.
Yeah. Now, to do this one, we need to remember the things you want to memorize on polar, or the 3 most important equations are these. R squared equals x squared plus y squared. X is equal to r cosine of theta, and y is equal to r sine of theta. That's it. Memorize those. So, so y equals 4. For some reason, I'm drawing a blank here. Well, what's r? In other words, if I plug into this one right here, I know what y is. It's 4. What's r based on this one right here? R squared is the square root, or r squared is equal to x squared plus y squared. So what would r be?
4 squared. So R squared equals x squared plus 8.
No, x is 0. So r squared is 4 squared. 16. So r
16.
is 4.
Yeah. Oh my God. Yeah.
So we've got 4 equals 4 sine of theta. It's not quite right. Do you have answers on these?
I do not. No.
I think, let's see, we're converting it to polar. Usually in polar you need an r and a theta. So I'm inclined to call that r. R equals 4 sine of theta would give you the horizontal line y equals 4. Or would it? Let's see, when theta is 0, r is 0. So you end up right there. So something's wrong here. Let me look at this a little bit more, and we can start here on our next session tomorrow.
Okay.
Okay?
Sounds
And
good.
yeah, we'll start with number 18 on this page.
Okay.
All right, Demetrius, I'll talk to you tomorrow.
Sounds good. See you tomorrow.
Good night.
You too.
Bye-bye.
Bye.